Stan Gibilisco here, proprietor and operator of amateur radio station W1, GV, Whiskey 1, good vibrations, at your service, to show you an example of an antenna that has imperfections of multiple sorts that cause a coaxial cable line to, in effect, radiate. Now, you wouldn't expect coaxial cable, which is supposedly shielded, to radiate RF energy. After all, isn't that what the shield is for? It sends the RF along up from the radio to the antenna as if through a water pipe. And if you've got really good coax with a really tight braid, you would think that RF couldn't possibly leak out. And literally, it doesn't. But in effect, things can happen that for all practical purposes result in the equivalent of RF leaking out of the line. And I'm showing some of those here. If you bring the coaxial cable away from the antenna, say a dipole antenna, a half-wave dipole antenna, it happens to be straight and horizontal in this case, but the ground underneath it is not level, and there is an obstruction here, a big tree underneath and near this side of the antenna, so this side of the antenna is more closely coupled to the ground than this side, resulting in unbalance at the feed point. There's no balun in use here, so that you're using a supposedly theoretically balanced antenna with an unbalanced line. Strike 3, and there are more strikes. The second strike is this obstruction here. The first strike not at a right angle. Strike 3 is no coax. Let's see, what could we think up as strike 4 might be? Well, you might cut the sides of the dipole to non-equal lengths. You might just get careless and make one side longer than the other. You might you might not make the dipole straight, although when it's hung between only two supports, it's pretty much going to have to be straight unless you let it sag to an excessive degree, which you could conceivably do. Inadequate insulators here. Perhaps the use of conducting wire here, and you just tie it to insulated wire with a good old Boy Scouts or Girl Scouts knot. A little bit too much coupling there, even though there's insulation on the wire, etc., etc. A lot of faults that make this antenna geometrically imperfect. Well, water can't leak out of a really good solid copper or aluminum pipe, literally, but in effect it can, because in effect the RF can radiate from this cable just as if it were leaking out because of antenna currents. Supposedly, well, that's what we call these things, antenna currents. The antenna, because it's not symmetrical with respect to the feed line and doesn't radiate its RF equally from both sides and all sides of the feed line, it tends to create a current along the shield of the coaxial cable called an antenna current, because this makes it act just like another element of this dipole antenna, and it will radiate in effect just as well as it would if the shielding were poor on the cable to begin with. So all of this sort of stuff can make coaxial cable actually, in effect, radiate RF even though it is supposed to be shielded. So don't take shielded to necessarily mean really shielded in practice. In theory, maybe. In practice, not always. In fact, usually not, because the perfect installation is actually rather rare and hard to obtain. But you can come close. This particular situation right here doesn't even come close. We're really having problems with this thing. So, time to get to work. Fix these imperfections. And if you can't fix them, you might want to try some other kind of antenna besides a dipole. And I'll see if I can maybe make some videos about those that can show some of the things you can do wrong and avoid so that you get the best for your buck and for your time and for your RF wattage. Stan Gibilisco, W1GV, signing off, saying 73, which means best regards in ham radio jargon, and so long, which, in my CW fist, and with this antenna cut for the CW part of the band, however many imperfections there may be in other ways, so long translates into da-da-da-da-da-da.